Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. So I was actually teaching the 12th chapter of 8th standard mathematics subject, that is factorization. So in this factorization chapter, I'll be uploading 3 videos. So part 1 video I have already uploaded and this is part 2 video. So similarly, there will be one more part, that is part 3 video on this particular factorization. So if you want to understand factorization, then go through all 3 parts so that you can understand all 3 exercises which are discussed in this particular factorization chapter. So in this part 2 video, I'll be explaining further how factorization is done using identities, and also I'll be solving the exercise 12.2 questions. So you should actually remember certain identities in this particular topic. Using that particular identity, you will be actually factorizing a particular algebraic expression. So one particular identity which you should actually remember is a plus b whole square. So a plus b whole square is actually a square plus 2ab plus b square. This you might have learnt because a plus b whole square is actually a plus b into a plus b. So when you multiply this, I have already explained you how to multiply an algebraic expression with another algebraic expression. So here a plus b will be one algebraic expression and another a plus b will also be another algebraic expression. So when you multiply those two, then each element of first polynomial should be multiplied with each element of the second polynomial. So here a should be multiplied with both a and b. So when you do that, you will get a square plus ab. And when you multiply b with both a plus b, then you will get b into a plus b into b, that is b square. So here ab and ba are nothing but ab plus ab itself. So ab plus ab will be 2ab. So 2ab plus b square. So that is what I have written here. So this is one particular identity which you should actually remember. And similarly, when you do a minus b into a minus b, that will be a minus b whole square. You will actually get a square minus 2ab plus b square. So this you can actually solve, and you also know the formula for this particular a minus b whole square. So similarly, when you do a plus b into a minus b, so now I have taught how to do a plus b into a plus b, how to do a minus b into a minus b. When you do a plus b into a minus b, you will get a square minus b square. So when you do a plus b into a minus b, at that time you will be multiplying a with a minus b. So that is a square minus ab, and b with a minus b, that will be ba minus b square. So this ba is nothing but ab. So plus ab and minus ab gets cancelled, and only a square minus b square will be remaining. So this is one particular identity which you should actually remember to solve the problems. So coming to one particular example. So x square plus 8x plus 16 is there. So this particular algebraic expression, you should actually reduce it to one of the identities and try to get the factors of this particular algebraic expression. So now we know that a square plus 2ab plus b square is actually equal to a plus b whole square. So here you can clearly see x square is there, 8x is there, 16 is there. So this particular equation can be written as x square plus 2 into 4 into x plus 16 can be written as 4 square. So here you can see in the place of a you have x, in the place of b you have 4. So x square plus 2 into 4 into x plus 4 square. That means here a square plus 2ab plus b square. This particular equation we are writing in the form of a square plus 2ab plus b square. Now you can see here in the place of a we have x, and in the place of b we have 4. So instead of writing this particular equation, we can simply write x plus 4 whole square. So that is actually x plus 4 into x plus 4. So the factors of this particular x square plus 8x plus 16 will be x plus 4 and x plus 4. That is x plus 4 into x plus 4. So like this, you should actually, by seeing the algebraic expression, you should actually recognize which particular identity can be fit in this particular algebraic expression which is given, and you should reduce that algebraic expression into that particular identity, and then you should actually calculate the factors of that particular algebraic expression. So as you solve more and more examples which is given in this particular chapter, you'll understand how to do that, and also I'll be teaching you how to solve exercise 12.2 questions. So based on all this practice, you can actually identify which particular identity can be best suitable to reduce a particular algebraic expression to get the factors of that particular algebraic expression. There is one more identity which is actually discussed in this particular concept. So that is actually x plus a into x plus b. So when you do x plus a into x plus b, it will be equal to x square plus xb plus xa plus ab. So here you can take x and x common in these two terms. So when you take x common, it will be x into b plus a plus ab will be outside bracket. So the equation which you are getting here is x square plus x into, instead of writing b plus a, I can write a plus b plus ab. So this is one particular identity which you should actually remember, so that when you actually reduce a particular algebraic expression to this particular form, so straight away you can apply this particular identity and you can actually get the factors of that particular algebraic expression. So let me solve one particular example based on this particular identity. So the example which is given here is 3m square plus 9m plus 6. So here, before writing this in the form of x plus a into x plus b, you can take this 3 common in all these 3 terms. Because here also 1 3 is there, here also 9 is there, in that 9 3 is there, because 3 into 3 will be 9, and in this 6 again 3 is there, because 3 into 2 will be 6. So I can write this as 3m square plus 3 into 3m plus 3 into 2. So here you can take 3 common in all these 3 terms. So when you take 3 common in all these 3 terms, it will be equal to 3 into m square plus, in the bracket m square will be there, plus 3m will be there, plus 2 will be remaining. So now you can take this particular expression. So let this 3 be there outside bracket. We will take whatever is there inside bracket. So inside bracket we have m square plus 3m plus 2. This you can reduce to m square plus 3 can be written as 2 plus 1 into m plus 2 can be written as 2 into 1. So here you can clearly see this particular equation is resembling x square plus x into a plus b plus ab. Here x, in the place of x you have m, in the place of a and b you have 2 and 1. So you can straight away write this as x plus a into x plus b form. So here x is m, so m plus a is 2 into, and b is 1, so m plus 1. So m plus 2 into m plus 1 will be the factors for m square plus 3m plus 2. But the total equation which we had was 3 into m square plus 3m plus 2. This m square plus 3m plus 2 is inside bracket and 3 is outside bracket. Now m square plus 3m plus 2 we have actually written in the form of m plus 2 into m plus 1. So 3 into m plus 2 into m plus 1. This particular m square plus 3m plus 2 is written as m plus 2 into m plus 1. So 3 is one factor, m plus 2 is one factor, m plus 1 is one factor. So 3 into m plus 2 into m plus 1. So all these 3 terms are the factors of this particular 3m square plus 9m plus 6. So like this you should actually use the identities and try to calculate the factors of a particular given algebraic expression. Coming to the exercise 12.2, here you have 8 questions in the first question. So I'll be solving 4 questions out of it. Remaining 4 questions similarly you can actually solve. So coming to the first question in this particular first question, there they have given a square plus 8a plus 16. Here in this particular algebraic expression you can actually use a plus b whole square identity. So you can reduce this a square plus 8a plus 16 into a square plus 8a can be written as 2 into 4 into a plus 16 can be written as 4 square. So you might be having doubt that how can we know that we should use this particular identity only. So always you should remember that if you have an algebraic expression like this, you should see this last term which is there. So if it is a perfect square number, then you should either use a plus b whole square or a minus b whole square. If that is not a perfect square number, then you should use x plus a into x plus b formula. So that means here the last term should be perfect square. The example which I solved previously, here we had m square plus 3m plus 2. So here 2 is not a perfect square. That's why here I didn't use a plus b whole square or a minus b whole square formula. I used x plus a into x plus b formula. In this particular question, you should identify whether this particular last number which is there in the algebraic expression is perfect square or not. If it is perfect square, then you can actually use a plus b whole square or a minus b whole square. So how to find out whether we should use a plus b or a minus b? So you should see whether negative term is there here or not. So if no negative term is there, only plus is there, then you should actually use a plus b whole square formula. So here 16 can be written as 4 square, 8 can be written as 2 into 4. So this particular equation is in the form of a square plus 2ab plus b square. So here a is actually a, b is actually 4. So here you can write this as a plus 4 whole square, or you can write this as a plus 4 into a plus 4. So this a plus 4 into a plus 4 will be the factors of this particular a square plus 8a plus 16. Coming to the third question in this particular exercise, there they have given 25m square plus 30m plus 9. So here you should see that this particular 25 is also a perfect square, and this particular 9 is also a perfect square. That means here either we should use a plus b whole square or a minus b whole square. Here everywhere plus is there, so that means we should use a plus b whole square identity only. So in the place of 25m square, I can write this as 5m whole square, because m square is there. So I have taken that square outside and I have reduced this 25 to 5. So 5m whole square will be 25m square plus 30m. 30 can be written as 2 into 5m into, here 5 2s are 10, 10 3s are 30 into 3, because here you should see in the place of a we have 5m. So here also we should get 2ab. So 1 a should be there. That means 5m should be there. So that's why I have splitted this 30m into 5m, and whatever number you should actually multiply to that 5m so that you can get 30m is 2 and 3, because 2 will also be there in the formula, because 2ab you will be having. So here 2a you have got, this will act as b, plus 9 can be written as 3 square. Here you can clearly see b is there, here a is there. So this is in the form of a square plus 2ab plus b square. So you can straight away write this as 5m plus 3 whole square. So, or you can write this as 5m plus 3 into 5m plus 3. So this 5m plus 3 whole square acts as the factor for this particular 25m square plus 30m plus 9. Coming to the fifth question in this particular first question, there they have given 4x square minus 8x plus 4. So here you can clearly see this 4 and this 4 both are perfect squares. So you can use a plus b whole square or a minus b whole square formula. But here negative term is there, that is minus is there in the particular algebraic expression. So that means you should actually use a minus b whole square. So 4x square can be written as 2x whole square, because 2x whole square will be 2x into 2x, that is 2 into 2 will be 4, x into x will be x square, 4x square will be remaining. So 2x whole square minus 2 into 2x will also be there here, because you should actually write this in the form of a square minus 2ab plus b square. So minus 2 into a will be 2x. So I have written 2x, and what more should be added here? 2 should be multiplied, because when you multiply 2 with 2 you will get 8 and x is there. So minus 8x will be remaining. Plus 4 can be written as 2 square. Here you can clearly see 2x is acting as a and this particular 2 is acting as b. So here you are getting in the form of a square minus 2ab plus b square. So 2x whole square minus 2 into 2x plus 2 square can be written as 2x minus 2, that is actually a minus b whole square. So, or you can write this as 2x minus 2 into 2x minus 2. So again you can reduce this particular 2x minus 2 whole square as, because here 2 is common in both the terms. This you can actually write as open big bracket, inside that write 2 into x minus 1 whole square, because here I am taking 2 common from this 2x minus 2. So here also 2 is there, here also 2 is there. So when you take 2 common from this x, only x will be remaining inside bracket, and when you take 2 common from this minus 2, only minus 1 will be remaining inside bracket. So 2x minus 2 can be written as 2 into x minus 1, and whole square is there, so that's why I have put big bracket and I have written whole square. Now apply this particular whole square to this 2 and for this x minus 1. So that will be 2 square into x minus 1 whole square. So 2 square is 4 into x minus 1 square. So here 4 is one factor, x minus 1 into x minus 1 is one factor, or you can tell this as 4 into x minus 1 whole square. So this particular fifth question has factors 4, x minus 1, x minus 1. So these are the factors for this particular fifth question in this particular first question. Coming to the seventh question in this particular first question, there they have given L plus m whole square minus 4lm. Let's expand this particular L plus m whole square, then we will actually calculate what particular algebraic expression we will be getting. So L plus m whole square can be written as L square plus 2ab. So a plus b whole square formula is a square plus 2ab plus b square. So L plus m whole square will be L square m plus 2lm plus m square. Now you have minus 4lm as well. So here you can see this particular term also has lm and this particular term also has lm. So you can perform subtraction between 2 and 4. So when you do 2 minus 4, you will actually get minus 2. So minus 2 lm is there as common. So minus 2 lm plus m square. Now you have got the equation L square minus 2 lm plus m square. You can clearly notice that this particular equation is in the form of a square minus 2ab plus b square. Here L acts as a, m acts as b. So you can clearly write this particular L square minus 2lm plus m square as L minus m whole square. So L minus m into L minus m or L minus m whole square is the factor for this particular L plus m whole square minus 4lm. That is 7th question. Coming to the second question in this particular exercise 12.2, there also you have 8 questions in this particular second question. I will be solving 4 questions. Remaining 4 questions you can actually solve similarly. So coming to the first question in this particular second question, there they have given 4p square minus 9q square. You can clearly see that this particular 9 is also perfect square and this particular 4 is also perfect square, and they have given p square and q square. So this is in the form of a square minus b square identity. So you can write this particular 4p square minus 9q square as 2p whole square minus 3q whole square, because 2p whole square will be 2 into 2, that is 4, p into p, that is p square. So 4p square, you will get the same 4p square as the answer. So you can write this 4p square as 2p whole square and this 9q as 3q whole square. So this is in the form of a square minus b square. Here 2p is a and 3q acts as b. So a square minus b square can be written as a plus b into a minus b. So here you can write this as 2p plus 3q into 2p minus 3q. So this 2p plus 3q and 2p minus 3q acts as the factors for this particular 4p square minus 9q square. That is the first question in this particular second question. Coming to the third question in this particular second question, there they have given 49x square minus 36. Here also you can see this is also perfect square, this is also perfect square, and this is in the form of a square minus b square. So you can write this 49x square as 7x whole square, and this 36 can be written as 6 square. So 7x acts as a, 6 acts as b. So you can write this as a plus b into a minus b formula. So 7x plus 6 into 7x minus 6 are the factors for this particular third question in this particular second question. Coming to the fifth question in this particular second question, there they have given L plus M whole square minus L minus M whole square. So here you can clearly see that L plus M is A, L minus M is B. So A square minus B square. If you consider this particular identity, here L plus M is A and L minus M is B. So you can write this as A plus B into A minus B. So here A is L plus M plus B, that is L minus M, into, you should actually write it in the form of A plus B into A minus B. So here in the second bracket it will be A minus B. Here A is L plus M. So L plus M minus L minus M, that is the B. So now you can actually solve this. L plus M plus L minus M is there. Here plus M minus M gets cancelled. So L plus L will be 2L. So here in the second bracket you have L plus M minus of L minus M. So L plus M, when you remove the bracket, it will be minus L. Minus into minus M will be plus M, because minus into minus will be plus. So here plus L and minus L gets cancelled. So M plus M will be 2M. So 2L into 2M. You can take this 2 outside. So it will be 2 2s are 4. So 2 into 2 will be 4. L into M. So 4 is one factor, L is one factor, M is one factor. So 4LM acts as the factor for this particular fifth question in this particular second question. Coming to the seventh question in this particular second question, there they have given x square minus 2xy plus y square minus z square. So here you can clearly see that this particular x square minus 2xy plus y square is in the form of a square minus 2ab plus b square. In the place of a and b you have x and y. So this you can straight away write as a minus b whole square, that is x minus y whole square minus z square. Here this is in the form of a square minus b. So this particular x minus y whole square minus z square is in the form of a square minus b, where a is x minus y and b is z. So this also you can write it as a plus b into a minus b. So a plus b means x minus y plus z into x minus y minus z. So this z will be there inside bracket only. So x minus y plus z, x minus y minus z are the factors for this particular seventh question in this particular second question. Coming to the third question, here you have 9 questions in this particular third question. After solving these many problems, you can actually easily solve this particular third question. But I will be solving 3 questions in this particular third question. So remaining 6 questions you can actually solve. So coming to the first question in this particular third question, there they have given ax square plus bx. So this is very simple. You can just take x common in this. So it will be ax plus b. So x into ax plus b will be the factors for this particular ax square plus bx. So coming to the third question in this particular third question, there they have given 2x cube plus 2xy square plus 2xz square. Here you can take 2 common, x common, because in all these 3 x is there. So you can take x and 2 as common. So when you take x and 2 as common, it will be 2 into x. So inside bracket x square will be remaining, because you are taking x from this x cube. So x square will be remaining. When you take 2x common from this 2x y square will be remaining. When you take 2x from this 2x z square will be remaining. So 2x into x square plus y square plus z square. This is the factor for this particular third question in this particular third question. Coming to the fifth question in this particular third question, there they have given lm plus l plus m plus 1. M plus 1 is outside bracket. So now you can take this lm plus l. You can take l common in this particular lm plus l plus m plus 1 is there. So when you take l common from these two, you will get l into m plus 1 plus m plus 1. So here if you separate this term like this, you can clearly see this can be written as m plus 1 into 1, because when you do m plus 1 into 1, m plus 1 will be remaining. So that will be plus m plus 1 only. So you can take m plus 1 common in these two terms, in these two big terms which I have separated. So when you take m plus 1 common in these two terms, what will be remaining inside bracket? L will be remaining and 1 will be remaining. So that is L plus 1. So when you solve this particular fifth question, you will actually get m plus 1 into l plus 1. So m plus 1 and l plus 1 are the factors for this particular fifth question in third question. So I'll solve two more questions in this particular third question. I'll solve seventh question in this particular third question. In seventh question, they have asked 5y square minus 20y minus 8z plus 2yz. Here you can take y common in these two terms, and you can take 5 also common in these two terms, and you can take 2 and z common in these two particular terms. So let us consider this as one term and this as one term. So when you take 5y common in these two terms, you will be getting 5y into inside bracket y will be remaining, because when you take 5y common from 5y square, y will be remaining, minus when you take 5 from this 20, 4 will be remaining, and you y also you have taken common outside bracket. So only y minus 4 will be remaining inside bracket. So when you take minus 2z common, then you will be getting plus 4 minus y will be remaining inside bracket, because when you multiply this particular minus 2z with plus 4, it will become 4 into 2 is 8, into z will be there, minus into plus will be minus, so you will get minus 8z as it is. So when you multiply this minus 2z with minus y, again you will get minus into minus plus 2z into y will be 2zy. So you will get this particular plus 2yz. So here this particular minus you can take inside bracket. So that will be equal to 5y, y minus 4. When you take minus inside bracket, it will become plus 2z. So when you take minus inside, it will become minus 4 plus y. So or else you can write it as y minus 4. Because when you multiply plus 2z with minus 4, you will get minus 8z, which is there in the question. And when you multiply 2z with y plus 2z with plus y, you will get plus 2zy or plus 2yz, which is there in the question. So here you can clearly see in this particular term y minus 4 is there, and in this particular term y minus 4 is there. This y minus 4 you can take as common, and inside bracket 5y will be remaining and plus 2z will be remaining. So 5y plus 2z. So y minus 4 into 5y plus 2z are the factors for this seventh question in third question. Coming to the ninth question in this particular third question, there they have given 6xy minus 4y plus 6 minus 9x. So in this 6y you can separate 2 and y. In this 4y also you can separate 2 and y. So when you take 2y common from the 6xy and 4y, you will actually get 3x inside bracket, because when you remove 2 from this 6, you will get 3, and when you remove y, then only x will be remaining. So 3x will be remaining inside bracket. When you remove 2y from this 4y, only 2 will be remaining, that is minus 2. Because when you multiply this 2y with minus 2, you will get minus 4y. Plus, you can take 3 common from this 6 and 9. So when you take 3 common, you will be getting 2 inside bracket, because 3 into 2 will be 6. Minus, when you take 3 common from this particular 9, 3 will be remaining inside bracket. And x will also be remaining. So 2 minus 3x. Here you can see you have 3x minus 2. Here you can see 2 minus 3x. When you take minus outside, again this 2 minus 3x will become 3x minus 2. So when you take minus common or minus outside bracket, at that time it will be equal to 2y into 3x minus 2 will be there as it is. When you take minus from this particular bracket, then it will become minus 3 into 3x minus 2, because when you multiply minus 3 with minus 2, it will become plus 6, because minus into minus will be plus. So plus 6 is there in the question, and when you do minus 3 into 3x, it will become minus 9x, that is also there in the question. So you can take minus outside bracket and you can write this as minus 3 into 3x minus 2. So here also 3x minus 2 is there, here also 3x minus 2 is there. You can take 3x minus 2 as common, and 2y minus 3 will be remaining inside bracket. 2y minus 3. So 3x minus 2 into 2y minus 3 are the factors for this particular ninth question in third question. So in this fourth question you have 5 questions. So out of which I will be solving 3 questions. So coming to the first question in this particular fourth question, there they have given a power 4 minus b power 4. So this particular a power 4 minus b power 4 can be written as a square whole square minus b square whole square, according to one particular exponent law which I actually discussed in the exponents and power chapter. If you have not watched that video, you can go back to the exponents and power video and you can watch. In that I have explained a power m whole power n can be written as a power mn, or a power mn can be written as a power m whole power n. So similarly here 4 is actually 2 into 2. So that's why I have taken 2 outside the bracket. So a square whole square I have taken. So according to this particular exponent law. Now here this is in the form of a square minus b square. Here a will be a square, b will be b square. That means here a square minus b square is one particular identity which I have discussed. In the place of a square minus b square, you have a square whole square minus b square whole square. So a acts as a square, b acts as b square. So that means here you can write this in the form of a square minus b square identity. That will be equal to a square plus b square into a square minus b square. Here this particular a square minus b square, again you can split into a plus b into a minus b. So a square plus b square into a plus b into a minus b. So here a square plus b square, a plus b into a minus b acts as the factors for this particular a power 4 minus b power 4. Coming to the third question in this particular fourth question, there they have given x power 4 minus y plus z whole power 4. This particular fourth question is actually similar to the second question problems which we have already solved. Fourth question is just an extended version of the second question which is there in this particular exercise 12.2. So x power 4 minus y plus z whole power 4 can be written as x square whole square minus y plus z whole square whole square. So this is in the form of a square minus b square. So here a is x square, b is y plus z whole square. So you can write this as x square plus y plus z whole square into x square minus y plus z whole square. So brackets you should never make confusion. You should properly put brackets wherever it is necessary. Because if you get confused in putting brackets, then you can go wrong while solving these kind of problems. So now you can see this x square minus y plus z whole square. This is also in the form of a square minus b square. So we can expand this as well. So x square plus y plus z whole square will be there in one particular bracket. In the second bracket it will be x plus y plus z into x minus y minus z, because x minus y plus z will be there. So when you remove the bracket it will become minus y minus z. So x plus y plus z, x minus y minus z. That is actually x square minus y plus z whole square. I am writing it as x plus y plus z into this into x minus y plus z. So when you remove this particular bracket, the bracket which is there inside bracket, so it will become x plus y plus z into x minus into y will be minus y, minus into z will be minus z, minus y minus z. So this equation I have written here, x plus y plus z into x minus y minus z into x square plus y plus z whole square will also be there. So here x square plus y plus z whole square into x plus y plus z into x minus y minus z acts as the factors for this particular x power 4 minus y plus z whole power 4. Coming to the fifth question in this particular fourth question, there they have given a power 4 minus 2a square b square plus b power 4. This you can write it as a square whole square minus 2a square b square plus b power 4 can be written as b square into b square. So this is in the form of a square minus 2ab plus b square. Here in the place of a you have a square and in the place of b you have b square. So you should remember that things. So you should actually remember these particular minute things, because if you go wrong here you will actually get wrong results when you solve these kind of problems. So here you can write a square minus 2ab plus b square as a minus b whole square. Here a is a square and b is b square. So a square minus b square whole square will be there. So this you can write it as a square minus b square into a square minus b square. So again this is in the form of a square minus b square, a square minus b square. So this you can again split as a plus b into a minus b into a plus b into a minus b. Here you can write this as a plus b into a plus b can be written as a plus b whole square. A minus b into a minus b can be written in the form of a minus b whole square. So a plus b whole square into a minus b whole square acts as the factors for this particular fifth question in fourth question. Coming to the fifth question, here you have three questions in this particular fifth question. I will solve two questions, remaining one question you can actually solve similarly like that. Coming to the first question in this particular fifth question, there they have given p square plus 6p plus 8. So 8 is not a perfect square. So here I should actually use x plus a into x plus b identity. What is x plus a into x plus b? X plus a into x plus b will be x square plus x into a plus b plus ab. Here you can write this p square plus 6p plus 8 as p square plus p into 6 can be written as 2 plus 4 plus 8 can be written as 2 into 4. So here p acts as x, 2 and 4 acts as a and b. So this you can straight away by using x plus a into x plus b identity, you can write this as p plus 2 into p plus 4. So p plus 2 into p plus 4 acts as the factors for this particular p square plus 6p plus 8. So coming to the third question in this particular fifth question, there they have given p square plus 6p minus 16. Here you can actually tell that this particular 16 is actually a perfect square. So here you can actually either use a square, a plus b whole square or a minus b whole square identity. But here you should actually see you don't have plus over here. So always you should remember whenever you take a plus b whole square or a minus b whole square, when you expand that you will get a square plus 2ab plus b square, a square minus 2ab plus b square. In both the cases you are getting plus b square plus b square. But here you have minus in this particular place. That means here you cannot use this particular identity. So you should use x plus a to x plus b identity only. So how to convert this particular p square plus 6p minus 16 into x plus a into x plus b identity? So here in the place of p square you can write p square itself. In the place of 6 you can actually write that as minus 2 plus 8. That means here you should actually write minus 2 plus 8. When you write minus 2 plus 8, you will actually get 8 minus 2, that is plus 6. So equation remains the same. So in the place of 6 I am writing as minus 2 plus 8. Minus 16 can be written as plus minus 2 into 8. Because when you do 8 into 2 you will get 16. Plus into minus, minus will be there. So 8 into minus 2 will be minus 16. So this minus 16 can be written as minus 2 into 8. So this is in the form of equation x square plus x into a plus b plus ab. That is minus 2 into 8. So this you can write it as p plus minus 2 is one term into p plus 8 is another term. That is actually x plus a into x plus b. So here when you remove this particular bracket, it will be p minus 2 into p plus 8. So p minus 2 into p plus 8 are the factors for this particular third question and fifth question. This is all there in this particular video. This was the part 2 video of factorization. Similarly, there will be one more part, that is part 3 for this particular factorization chapter. When you go through all part 1, part 2, part 3 videos of factorization, then you can understand this particular factorization chapter very easily. So like this, I will be uploading more physics, chemistry and mathematics videos starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my YouTube channel and stay tuned with my YouTube channel. Thank you.